Good afternoon, everyone. It's Darius Bucher from Integral Forest Management. I'm the Canadian rep for RTI, the makers of Teabag Fertilizer. So the purpose of the video that I'm wanting to show you today is to bring you to another one of our long-term fertilizer trials. This one's 17 years old and is located in the McLure fire, which burned in 2003. The location of the block is probably 14-15 kilometers due west of Barrier, and it's located in the MSDM2 Beck zone. So this block in particular, I also walked it right after the fire had happened and took a look at it, and it burned extremely hot. Most of the trees in this area had been blackened. There wasn't any foliage left, there wasn't any cones left. Most of it, there was just basically the remaining stems. So this area was also not merchantable. So under the Forest for Tomorrow program, because of that, we were able to come in and do some rehabilitation work. Now, something that we did that was a bit of an experiment at the time was to take the equivalent of a D8 cat, and we did 3 small trial blocks, less than a hectare each, to see if we could knock down the timber and still have enough planting areas or planting space for the seedlings. So we did that as a trial. We knocked the timber to the ground. The cat passed over it a couple of times to really mash it into the ground. And there wasn't any burning done, there wasn't any piling done. So the slash that remained on the ground was basically laying just as it was crushed. We came back after, and there was lots of plantable spots in the area, gave us excellent protection, not only from the competing vegetation that might come in, but also from cattle damage. So we came in and we planted the site, and we used, but at that particular time, it was just a plant without any fertilizer. We came back about a month or two later with different funding under Forest for Tomorrow, and we were able to plant the remainder of the block that had been done and also do the site prep treatment. So this block is about 40 hectares in total. This area, as part of the funding, was also a trial to see the benefits, if there was any benefits to fertilizing these sites that had been burned extremely hot, where the nutrients the nutrients had been basically fried off. There wasn't any duff left. There was just compacted till, essentially. You could hardly get your shovel into the ground at the time. So that was the rationale for doing that. So we came in and we used RTI's Continuem Fertilizer. Now, these tea bags were still the older technology. We were not able to place them in the same hole like the PHP tea bags that we have now. So they would have all been placed an inch or two away from the seedlings. So this is what, once again, the purpose of the video is just to show you the differences between the treatment and the control areas after 17 years. All right, so now I'm standing to start off with in front of what I would consider to be your typical control trees. Now, this was a B-class seed lot that we used for this particular area. That was what was available to us at the time, and it was not fertilized at the time of planting. It was just planted amongst the slash. Trees were planted amongst the slash in the best microsites available. Okay, now I'm standing in front of what would be your typical trees that were fertilized at the time of planting with RTI's Continuum blend. The one thing to note is that this is an A-class seed lot. So because it was a different entry as far as when we planted this area, we ended up having different stock that was available. So the one difference between treatment and control is the fact that control area is B-class seed lot, and the area fertilized at the time of planting would be your A-class. Okay, here's another perspective view. Right now I am standing on the boundary between the treatment and the control areas, with the control area being on my left, treatment on my right. So we're going to just do a quick shot. Hopefully you'll be able to see the differences between the two. Okay, so what happened? What does this mean? So although I was not able to come back and to measure these trees this year, the trees are just getting too darn tall. By year 17, they're starting to get way beyond the height of my height pole that I used to measure trees with. So the last measurements that I have would have been based on year 15, 2 years ago. So at that particular point in time, all the data I'm giving you is from year 15. We're looking at differences in height of approximately 150 centimeters or 1.5 meters between treatment and control trees. So this is essentially a 24% gain. Your trees fertilized at the time of planting would have been 7.8 meters tall, and versus the controls, which would have been 6.3. Now, I understand that some of this height difference is probably a result of genetics, but what is really important here is the fact that the trend that I am seeing is consistent with other long-term trials that I have measured. So this is not really a surprise to me at all. As far as diameter is concerned, we're looking at diameters for your trees that were fertilized at the time of planting with Continuem, about 14.4 centimeters versus 12.8 for your controls. So we got a 12% gain in diameter, or roughly about 16 millimeters or 1.6 centimeters. But the volume is where the multiplication factor really comes in. And volumes at the end of year 15 were 53% larger for your A-class fertilized trees at the time of planting versus the B-class controls. So quite a big difference. Now, something that I would want to mention with regards to genetically improved seed, and I've been trying to make this point for years, is I don't really care how good your genetics are in the trees that you're putting out here. Just because you plant genetically enhanced seed does not mean that you're going to ever reap the benefit. How you treat that tree at the time of planting is what's going to cause it to be able to blossom. So that comes down to a proper microsite and balanced, readily available, good nutrition. If you don't have those things going for the tree, it's going to hinder its ability to be able to ever make the most out of the genetic gain that has been done at the seed orchard. Okay, so I'm standing now in the A-class fertilized at the time of planting with Continuem area of the block again. But I also thought what I wanted to do is, because at age 15 the trees were large enough, I could put them on growth and yield curves and project future volumes using Tipsy. And I chose age 50 because it's close to the biological rotation age of these stands. So what did I find? I found that the B-class control at the age of 50 years, the gross volume per hectare would be roughly 290 cubic meters. But the A-class seed that was fertilized at the time of planting with Continuem would have a volume per hectare estimated at 460 cubic meters per hectare. So this is a difference of 170 cubic meters per hectare at age 50. That's substantial. That works out to 160% gain over not fertilizing at the time of planting with your B-class trees. Now I understand, once again, this throws some cloudiness into the data because we're comparing there's some A-class or some genetic differences between the two seed lots, between treatment and control. However, when I look at my other sites, once again, this is the same trend that I would have found, maybe not as an extreme again, but it's the same trend that I found on a site that was near Oyster River on Vancouver Island, near Campbell River. It was also the same trend that I found on our Lemieux Creek site, which is now 19 years old, just up the valley from here. And in those areas, the genetics that were used were exactly the same between treatment and control. So one thing that I did do is, using Tipsy, and this is kind of nice, is that I could create a sort of a surrogate A-class control and what it would look like in order for comparison purposes. And what I did was take this A-class control and took it and fertilized it broadcast just before canopy closure at age 15. And this is what I found, is that we would end up with an approximate gross volume of 327 cubic meters. So this is a volume gain of roughly 37 cubic meters, or 13%. This is substantially less than fertilizing your A-class seed at the time of planting and letting it go for 50 years. So the message that I'm wanting to send here is that to really determine the trajectory of your stand, to get the most volume out of that stand, the time to set your trees on the right course is at the time of planting, and to give them the balanced nutrition that they need in order to do what it is they want to do. And of course, the first thing that they do when they're given that nutrition is build their crown, which allows them to build a bigger root system, which gives them the opportunity to capture the site, to capture sunlight in a way that is far greater than if nothing was done at all and they were struggling to get nutrition. So, very important message to learn from this whole thing is fertilizing at the time of planting is key to getting the most out of the genetic material that you're planting onto a site. Thanks again for watching, everyone. And if you'd like to take some time to be able to digest this data, I'd strongly suggest that you get a copy of the 15-year trial results. I'm more than happy to send it to you. Just send me an email, integralfm@telus.net, and I will make sure that you get it in your direction. We'll talk to you later. Thanks again.